These are a bunch of projects we've done over the years. It also shows some things that we've run across too to look for, but it just gives you some idea of the scope of projects we can do, we have done, and continue to do this day. If you look down in the opening of the slats, you can see the beam where it's got cracks developing. Typically I look at it farther back to look at a straight edge along the bottom of the beam, and if you look back farther you'd see these cracks travel not only here but left to right in that beam as well. Number 3 is a severely worn slat, and you can see the crack that travels across the face of the slat and a crack that's developing in the bottom of the slat. From left to right you can kind of see it comes up on the height of the slat, and then to the right it basically disappears. Here's a representation of a beam not being placed properly on top of a post. You should see a minimum of 3 inches of that beam bearing on top of the post. Where I get that number is from slat manufacturers. They say they want to see at least 3 inches of that beam bearing either on the post or end wall. A good solution to end wall issues that we see is a lot of people are pouring posts at that location. Just kind of a cheap insurance thing. Here's some really bad sagging slats. I get asked that question a lot. There's nothing wrong with these at the time. We did end up replacing these slats 3 years after that. The bigger issue here, if you can look in the openings straight forward, you can see the beam, and the beam has a lot of cracks in it. Here you can see where we're replacing the new to the old slats. This was several years ago where we were using singles, and it's just a good before and after picture all in one. Here's a picture of the same barn, but you can see how severely cracked the beam is on the right and the new beam on the left, and the new beam on the left is actually bigger as well. Here's a gestation barn where I ended up having to slide the G-stalls over out of the way to get the old slats like on the left that were in there and the new slats on the right installed. Here's a picture of another gestation barn. It's an older gestation barn that had several different sizes in it, none of them being common length. If you look at the slat on the left hand side in the middle here, you can see that it has an open end on it. That's why it was manufactured that way. They turned all their entire facility from farrowing over to all finisher space. Here's a barn that they had solid concrete down the middle. They wanted another area that was able to be slatted for pens. We came in, and in 7 days we broke the concrete out, dug it down, poured the cement in the bottom of the pit, and then set brand new slats on it, giving them another row of slatted area. It's just a shallow pit with a flush gutter in here, and the next pictures represent that as well. Here we broke up the concrete and removed it and started to dig the extra fill that was put in there. Here we'd poured the concrete floor, and we had to put a dividing channel in the pit itself before we could put the slats on. Here you can see where we actually poured that curb down the middle of that pit, and we've started installing the slats. Here you can see the completed project, where originally it was poured solid concrete, and we took that all out and dug it down, and like I said, in 7 days we gave them the finished product of a slatted floor. Here is a bunch of nurseries that we did at one time. They had plastic flooring in them. We removed the plastic floors, removed the gates, and inspected the beams. This site was only, I believe, 15 years old, or a majority of them were, and we ended up installing slats in them. Here's another picture of that same plastic floor. I believe there was 56 barns we did over a 2.5 year time span. We changed all this out, and like I say, we installed concrete slats. Here's a completed installation of slats in the plastic floored barn, or what used to be nurseries. They utilized them as nurseries after they installed the concrete flooring. Here's an old dairy barn that we took all the slats and beams off of. As you can see, this is a wide open pit. We installed posts and brand new slats and beams. Here you can see we installed posts in the proper location to set our new beams out, and then in the front of this picture you can see the new slats that we've set out this far. Here you can see, a majority of the floor being set on this old dairy barn, and in the distance you can see the posts that we've set in the pit, and just waiting on beams to be set and the concrete floor to be set there. This is a beam failure. I believe this barn isn't even a month and a half old. It was some poor product that a manufacturer had made. To my understanding, that company is no longer in business. Here's another beam failure. Like it says here, it's from the fact that the beam was never properly placed on the top of the post. It was just barely on there by 3/4 of an inch, from what I could gather, but ultimately it slid off the post and failed. And this is the end result. Here's a catastrophic failure. The area that fell in was 12 feet wide, where you can see here, and then it's 30 feet deep. And we ended up changing the direction of the way the floor got put in here. Left to right is the narrow width of the building, and fore and aft, or bottom to top of this picture, is the lengthways. The beams, you can see the beam pocket to the right, running to the post. We actually ran the beams the other direction, and then we changed the direction of the slats as well, just simply because we could get 12-foot beams and 10-foot slats. Because of the urgency of the failure, there was actually pigs in the pit that fell in as well. This is another gestation barn. The pit is 10 feet deep, and what you can see throughout this picture is an 8-foot tall wall that was a divide wall. This pit was divided into 4 pits, and the divide wall had failed. I believe it was a cause and effect. To the right, the pit pumpers had come in and pumped the pit down. and there is flow through holes at the base of this wall that should allow the liquid to flow back and forth. It's my belief that they were plugged, and there was so much hydraulic pressure on the left hand side of this wall that it made it collapse.